So what are the best conditions to watch this?
Well, actually, since it's a fairly large event, you don't really need anything except a clear sky, and just stand out in your yard and watch the moon.
So you don't need to be in a dark place, like getting away from the city.
Again, luckily enough, it's bright enough. Now, of course, the darker skies do help, especially seeing the shadow actually crossing the face of the moon. But it's not particularly that important.
So where do you think is the best seat in our region to watch this?
Well, what about our observatory?
Yeah, okay. And it's called the Moore Observatory.
Yes. It's called the Moore Observatory because Robert and Elizabeth Moore donated $1.3 million to Columbia Basin College back in 2003 in order for us to build the observatory. And his one request was it was built on the campus, which is kind of unusual for an observatory, because most of the time observatories are built where?
On a mountain.
That's right, on a mountaintop somewhere, right? But he wanted to make sure that the public had access to the observatory and that the students had access to the observatory, which has worked out real well for us. Yeah,
that's a very special donation. So tell us about the event that is Saturday, the times, what we're going to, if we show up, is it free? Tell us about it.
Okay. We are going to open the observatory for the public. We're going to open about 6 p.m. Sunday evening. The moon will rise about 6:41 p.m. and it'll already be in the partial eclipse at that point. So we're kind of lucky this time because since it's starting on the west coast of the United States, we get to see it early in the evening. And it's going to be visible throughout most of the northern hemisphere. Just that by the time it gets to Europe and Russia and China, it'll be in the early morning. But it'll be the early evening here, so it makes it fairly easy for us to observe it. It goes on from, the partial goes on through until about 7 or so, and then that's when it goes into totality, when it's totally in the shadow of the Earth. Basically what a lunar eclipse is when the Earth is blocking the sun from the moon, and the moon goes right into the Earth's shadow. And so it's going to, and this is going to be a fairly long one too, because it's, as far as totality, because the moon will go almost directly down the center of the Earth's shadow.
So when we look into the sky, I mean, what are we going to see? What are we going to see?
Well, initially you're going to see, it looks sort of like it's going to go through phases of the moon, where there's chunks being taken out of the moon, like it's, like normal, like quarter phases and so on. But then when it reaches totality, when it goes in completely into the Earth's shadow, it actually turns into a slightly orange, almost reddish color. And that's because of all of the sunsets and sunrises across the Earth are causing this reddish color to appear on the face of the moon. So it's a very interesting series of events. Initially, you're just going to see the shadow of the Earth encroaching on the moon, and then it'll slowly change into that orangish red color.
Oh my gosh. Okay, we're going to take a, yes, isn't that? We're going to take a break here, but when we come back, we're going to find out why it is best, if you're really interested in this, to watch it from the observatory versus your front yard. All right, we're back in a moment. Mike Brady is my guest right now. He's in the studio with us, and he's here to talk about the Eclipse Super Moon and the great event that's going on at CBC, the Moore Observatory, on Sunday, September 27th. So put that on your calendar. And the event basically starts at 6 o'clock. So Mike, when people come there, is this going to be outdoors, indoors, what?
Well, actually, it'll be a combination of both, probably. We will have small telescopes set up on the outside of the observatory, excuse me, for people to look at the moon as it's going through the eclipse phases. But we will also allow people to go up into the main observatory and take a look at it through the large telescope also.
See, that's extra special. I
It
mean,
is.
being in the front yard is good, but this is extra special. And then will folks be wandering around kind of explaining things as well, at least?
Yes, I expect to have myself and I have a student worker named John Cole, who is excellent at this sort of thing. He helps me out on Friday nights during our public shows, which, by the way, every Friday night throughout the year, most of the year we have public shows for the public just to come out. It's a free event. We're open from 8 to 10 on those evenings. We're closed during the winter from basically Thanksgiving through the end of February because of the cold and the clouds. But through most of the rest of the year, we're open every Friday night from 8 to 10.
Yeah. So also, if you come to this event, maybe you want to bring along a jacket
Absolutely.
when the
It's
sun
gonna be a
goes
little
down.
cool. That's
yeah.
right.
And what about a chair?
That would be a very good idea.
Yeah.
We have a few chairs there, but most of those are going to be inside the observatory, so a good lounge chair would be a great idea.
Yeah.
Absolutely.
And then you were just mentioning during the break too that you can use your binoculars to get a pretty good look if you were at home, for example, or even if you come to the event.
Yes, we should. Well, I think we have about 8 sets of binoculars, but if you have your own, that would be a good thing to bring too, just to get a closer look at the event.
Where is the Moore Observatory located? I mean, is it round? Would we notice it if we drove around in the CBC parking lot?
Actually, it's out near the ag area where the ag department grows their crops. It's also just on the other side of the baseball field. So if you know where the baseball field, which is on the far western edge of the campus, that's where it's located. And yes, it is a big silver dome.
Okay, well that will be easy to locate then. Okay, what else is the Moore Observatory used for? So you mentioned this Friday night event as well.
Yes. Well, of course we have astronomy classes for our students that are interested in the sciences. And so we have two different astronomy classes, Astronomy 101 and Astronomy 102. Astronomy 101 is basically on the solar system and kind of centers around those topics. Astronomy 102 goes into the galaxy and the universe and kind of concentrates on those areas of astronomy. And we also are tied in with the planetarium at the CBC campus. So between the two of them, we're really lucky here in our campus to have both the planetarium and the observatory that are available for not only the students but for the public to come and learn about science and astronomy.
Wow. So is information on the CBC website if people wanted to learn more about this?
Yes, we have a website for the planetarium and a website for the observatory both, and they're linked. If you just go to the Columbia Basin webpage, you can do a search for the planetarium and the observatory. It has phone numbers, times. There is a cost for utilizing the planetarium, but it is very reasonable. All that information is available on the webpage.
Otherwise, what are you using the telescope for? I mean, what can you see in space from this telescope?
We get asked that question a lot. Usually it's how far can we see kind of thing.
Yeah.
It's more based on how bright of things can we see. Basically, a telescope is, whether it's a refractor or reflector, is basically a light bucket. Which means we're gathering as much light as we possibly can from very distant, dim objects in order to see them better. The magnification comes from the eyepiece itself. So mostly what the telescope is doing is gathering enough light to then magnify it from the eyepiece. So the larger the mirror or the larger the lens, the more light we can gather, and the dimmer and the more distant objects we can see.
Mm-hmm. Well, for example, that night, will we be able to see any craters of the moon and that sort of thing?
Oh, yes.
Ooh, okay.
Yeah, we're looking through the
All
large telescope, the main, which is a 16-inch reflector telescope. You can pick up some pretty good details of the craters in the mountains and so on the moon.
Well, tell me from your perspective, because obviously you're somebody who follows this and studies it in terms of space exploration and what is fascinating you these days about new discoveries?
That's a really good one too, because I'll tell you what, the really exciting things are going on with NASA in particular. And there's a lot of private companies getting involved apparently right now to try to get out into space. Mars has been really heavily studied with several Explorer robots on Mars. And if you were watching the news recently, you probably saw about Pluto, that we had a spacecraft that went by Pluto and took some really close-up photos of Pluto and got some really good views of what Pluto actually looks like. So yeah, really exciting times going on right now. It's unfortunate that we spend more of our money on the military and other things like that. We should be putting more money into NASA as far as all of us in the astronomy field. It's amazing how much NASA is able to do with just a small amount of budget that they have.
Mm-hmm. Why? Why do we want to know more about space? What is our benefit there?
The list is too long to even mention.
Oh, come on, give me a couple.
Well, for instance, from the Apollo space program, most of the computers, most of the way that our cars work, most of the ways that we even cook in our kitchen are a result of the Apollo space missions. From Teflon coating to insulation of our homes, solar power. There's a number of things that come out that are utilized by everyday citizens from all of the space program aspects.
Okay, so see, that wasn't that hard, and that made a lot of sense. So let me ask you this. What do you think? Do you think that there is life on other planets?
The odds are yes, only
Okay.
because of the numbers. For instance, it's only been in this last century that we've realized that there are more galaxies than our own galaxy, and that was a direct result of Edward Hubble. He was able to figure out that the Milky Way galaxy was not the only galaxy by measuring distances to what's called the Cepheid stars, variable stars, and by figuring that out, he was able to figure out that, for instance, the Andromeda galaxy was not within our own galaxy, it was a separate galaxy, and then it just expanded from there. So one of the things that the Hubble Space Telescope was able to see was they pointed the space telescope into a blank piece of space about half the size of your thumbnail, and opened up the aperture for 10 days. And at the end of that time, there were literally thousands of galaxies in that tiny piece of space, and that just opened up the fact that there are billions of galaxies.
Wow. Okay, so there's a lot more to be explored, that's for certain, isn't it? It does.
It really
does.
And that's one of the reasons to go to the planetarium, because then you can see those things in a video, and to have our very knowledgeable personnel talk about that.
All right, I want to review with people because it is Sunday, September 27th from 6 to 9 p.m. basically at the observatory, the Moore Observatory on the CBC campus, and you'll be looking at an Eclipse Super Moon. Mike Brady, thanks for joining us today. We've learned a lot. Thank you.
Glad to be here.
All right, we'll be back in a moment.